Just going to do a little video here of a walkthrough how to create an image in Docker that can then be pushed into ECR, and we can run that from either a step function, or from a Lambda function, or from a Fargate function, both of those within a step function itself. I do these a lot of times because I find the documentation is not very clear, and some of the little demos that you can see out there, they either get down to into low level. So this is kind of a nice high level thing for myself. I can come back later and look at it. So mostly this is a video and a repo for myself, but hopefully others will find it useful. So again, the idea here is we get some basic logic. This is going to be really simple stuff that I'm going to do here. It's just a timer, but it could be a much more complex logic. Package it up into a Docker container. I'm going to use the Lambda base image because I want to use it for Lambda itself. Push that into ECR, and then once that container is in ECR, we can use the same container either in Lambda if this function is fairly quick, something that can happen in less than 15 minutes and within the resources, or you can go over to Fargate if it's going to be something that's going to run for much longer, or you need some bigger resources available. And then I'm just going to call out those multiple times through a step function, and I call them individually here and here in the test. But at the end of the day, we want to be able to set up, so, if you wanted to do 100 of these, it's kind of like AWS batch, but just through a step function, where we can call them directly from Lambda or from Fargate itself. Very simple way to kind of run through a bunch of logic for a specific container. So again, I've created a brand new clean AWS account. So if you see the account number, don't get too excited. I'll have that deleted by the time this video is up. We can see right now there's nothing in ECR. We don't have a repository. There are no Lambda functions, no state machines, and no S3 buckets itself. So starting with a completely clean thing. And again, I like to first do it in the console, figure out how to do it there, bring it back into the CLI so I can kind of see all the pieces that have to get built up. And then from there, bring it over into infrastructure as code. But doing this, I find, is a good way to make sure you understand all the concepts. I also put everything in environment variables. You obviously can control that in a different way than just doing these declarations here. But that way, if we change things, you can just come in, change your environment variables, and that's all you have to do. Obviously, the account ID, the bucket, and the profile is going to be different. I also set my CLI up. This assumes you have your CLI installed. I set it up with SSO, but you can do it however you feel is most convenient. So the first thing, again, I've already set these environment variables, is to create an S3 bucket. And just here, the S3 buckets obviously have to be globally unique in their names. And you can see I just set that environment above to today's date. Perfect. And so now when I go in here, we can see, excellent, we've got our S3 bucket ready to go. Then there's a bunch of roles that we're going to have to create. Lambda is pretty straightforward. It's the basic Lambda execution role that if you're doing it through the console, it creates this for you automatically, but you can just have one here. It does have to be able to write to S3. So we're giving that. With all of these, you'll see I'm using little sed commands again, so that when we look into the, for instance, S3 write policy, it just says bucket. That way, least privilege, it can only write to that bucket. It can't write to anything else in S3. So yeah, let's add the S3 inline policy here. Create the role for the step function. What was that? Oh, that's Lambda function. Okay, yes, the step function. Again, it's the standard step function. The step function actually is a very interesting one here. Let's see, step role policy. If we were just doing the Lambda function, you just need the ability to evoke that particular, again, least privilege. I'm just allowing it to evoke that one Lambda function that we just created. But because we are doing the ECS through Fargate, it's a little more complicated. So the step function has to be able to go in and create tasks, and it's got to be able to pass roles in. So the first one, it just needs that pass role into ECS tasks. The other one is it needs to be able to take a task definition and then run it as a task. So again, taking that task definition, only that task definition, and running it. And then the other thing is, because we're going to want to be able to see the step function, you could have the step function just call the task and then leave it. But we want to actually track it and make sure we see the status coming back. And so because of that, we have to be able to go and stop the task when that lower level job is finished, and then also describe it. So it's checking it, seeing when everything is finished, and then when it's finished, saying and going in and killing it. The other thing is it's because we're sitting there and getting that information, and we're telling it to complete the task once the underlying job is finished. We need to put these rules in. So these last three or last four, like I say, are the fact that we're using ECS. Lambda, again, much simpler to everything through Lambda. Cool. So let's see, where was that? The last one I did was the step role. Okay, so I created the role. Then I'm just going to go in and add that inline policy to it. The ECS also has two different types of roles. This was something that was a little bit silly for me, was there is an execution role and the task role itself. So the execution role, very standard, just uses the standard ECS task execution role. Whereas this one goes in, and this is when it actually runs itself. So this one is a little bit more unique. Okay, just make sure which one I did. And that one also has to be able to write to that S3 bucket, very similar to the Lambda function role that was created as well. So two different roles here within ECR. Again, that's something that I found wasn't very clear. Now that we've got all that, let's get into the more interesting things where we're going to build that Docker image locally. I've actually already run this just recently. I just finished this, but you have to be able to provide Docker the ability to push into ECR. So that's the command there. Then I'm going to go in and create the repository. Then I'm going to tag the image with latest so that when it goes into ECR, it's got that latest tag. And then I am going to push the Docker image into ECR itself. 1, 2, 3. And actually, while that's doing this, the app, the interesting thing again is the fact that you can run it from both Fargate and from Lambda. And to do that, you kind of have two different entry points. One is the standard, Lambda handler. And then when you're running it from Fargate, you actually can use like the command line here. So you run it and pass in some command line arguments. And this is also something you can use when you're testing locally. So both of them have a job ID, a duration, and a bucket. And then up here, you can see it just picks this in. Job ID is going to be tagged with the bucket. So when it writes at the bucket, it gives it the name with the job ID in it. And the duration, so you ask it to run for 3 seconds, it'll come in here in a loop. And then it actually measures the actual duration of that. Obviously, this could be doing something a heck of a lot more interesting than this. And then just dump that out to a file in S3 so we can see it happen. And the other thing that's a little interesting is, well, we'll get to it a little bit later. But yeah, that command here overwrites, just in case I forget to say it later, this command so this is what you have when you normally do Docker. And you have to use the Lambda base image, but because of that, it's a little bit interesting when you then go and try to use it from Fargate. So because we're using the Lambda image here, you also have to deal with the entry point as well. So that's the command that you're going to have to override, and you override it again with something like this. So we'll show that again as we go a little further. So now ECR. Boom, there's the ECR repository and the image that we just pushed up, which is fantastic. Okay, yeah, so let's create the Lambda function. Now that we have that ECR, again, that image can be called from both Lambda and from Fargate. So let's create the Lambda function first and just change the timeout here. It's normally 3 seconds, which is, well, we're asking for a delay. This is something I get hit all the time. It takes a while to actually create the Lambda function, so you got to wait a few seconds before you make that second command. And then let's go into Lambda, make sure they got created. You can see here now, boom, there is the Lambda function, and let's test the Lambda function. And you can see again, we're passing in that job ID of 1, duration of 5, and then the bucket number itself. And the bucket, which was over here, we created, has no objects. And now if we check it, boom, we can see it's got that one object in here. And let me just cancel this, do this through here, it's much easier. Yeah, second one I did for 2. And there we can see duration of 5. So we asked for 5, and then it had dropped it, and it's a duration of 5 as well. So fantastic. This is just if you need to update the function. So now we have the function working interestingly, and now we'll get the step function. So we can call the Lambda function itself, which is fine. It's a good test. It ran, it dropped that file in S3 properly. So now we're going to create a step function that calls the step function state machine, same thing. So here we just created that one-liner. And actually, I find it's easier to look at it like this. So here we have a little batch with a weight that we pass in, and then a timer. So this is the Lambda function that it goes and calls. And if we look at the code itself, we could see these has a map. That's the where you have you ask for 2 instances, so it maps the data into each of the instances. It takes that information, which is, let me just show it here. So you kind of have those. That's a list, and so in each list, it takes each of these objects, passes it into each instance, and then you can unpack from here, right? So delay. You can see that's the delay one, and then run through. Cool. Sorry, let me get me back here. Okay, so I created the function, and let's invoke the function. Let me just cancel out of this so that it doesn't think I'm editing it or something silly. And actually, one of the things I want to do is, we'll probably do this again here, because I like to clear my bucket first. Deleting those, and let's just make sure we see that. Okay, good. Let's execution. There we go. There's the 2 executions. It ran properly, but I deleted everything. It ran too quick. That's why, again, it's nice to do it with Lambda. So let's go and invoke the function again. What I'm looking for is to see, and let's go back here. Here's my second. See, it goes so fast, which again is great, but boom. And there's the 2 files that got created because we have the 2 durations. It's great. You can kind of see in here the 2 different batches that went through. Of course, they do 0 indexed, but you can see the information we passed into that one, and then the information we passed into that one. And then we go state view. Again, we can see that the first one went right away. The second one waited for 2 seconds. And then the duration, you can see the duration is a little bit, so 4 seconds, 4.5. Lambda takes a little bit to run, so that's the duration of the full Lambda function. Whereas if you look into these files, let's just cat them out again. I won't keep doing the catting once we do it further, but let's do it here. We can see duration of 3 and 4, and that was what we asked for here, 3 and 4. Cool. And okay, step function. So now let's do it through Fargate. First thing we have to do is create a cluster. There we go. We create the cluster. Now we're going to go in and create the task. Whoops. Definition itself. And well, that's just only takes a second, but task definition. We can see in here, one of the interesting things is, yes, this entry point that I kind of mentioned earlier. Again, because you're using the Lambda base image, you'll have to go and override that entry point. Again, one of the things is not very clearly stated in the docs, but an important one, or you won't be able to get that to run properly. And we've created the task definition. So now, for instance, if we go into, let's see, ECS. Whoops. So now we just created this cluster in here. We also have the task definition that's here. You can see I did a one previously. It's got two definitions. It'll always pick the latest when it runs. And now let's run the task. To run the task, you have to pass in the information about the VPC, the subnets, and the security groups. It's a little bit annoying. The way I did it was kind of list out the subnets, take care of the quotes, see the single quotes on the outside and the double quotes inside. So with that, there we go. So now we have got running the task. So let's go into this cluster task, and there we go. It's provisioning. This is the one that has just started. It takes a little, like the Lambda was super fast. That's why I like doing the Lambda. This takes a little bit longer to spin up. And then also you'll notice even when it's finished, and you'll see, did I forget to clear this out again? Yeah, 24. So that one actually just came through. I should have deleted those. Let's remove those two. And we could do a fresh one. Yeah, so it already finished. There we go. What we're going to do now is just run it again so that you can see that it's empty, and then let's run the task. The other thing that's interesting when you're running the task, you can see this is the command. So it overrides that command, and this is where we're passing in the information about the job ID, so job ID 2, and then the bucket. So when it runs now, you should just see job ID 2 getting created. So let's filter. Here we go. There's the pending task. Again, it takes a little bit longer. It takes a little bit of time to spin up, and then it runs really fast once it starts, but then for it to stop. So even though, for instance, see if I can do this. See, it's already finished that job. See job 2, but it still has the status of running, and it takes a little while for it to finish up. You'll see it again when you do the state function. Cool. So that is running the ECS task. So now that we can run the ECS task, run that same image from the ECS task, we can now create a step function that calls the that ECS Fargate task itself. And let's just go in and have a look at the step Fargate definition here. Again, this is the subnets that I talked about in the security group. That's why it's a little bit ugly when we pass it in. And then here's down is the commands. So when we're running it from the CLI, the task, we put that command into the CLI command itself. Here it's actually passed in as part of the definition. And then when we run the step function, this gets updated. This gets pulled out, and we'll see that here. So this is the step function definition. And so when we pass in the information, just how we had like the delay gets pulled out of the inputs, the commands also get pulled out of the inputs itself. So that is the definition. And so let's go over to the step function. So state machines. Now we have a new state machine called Fargate. And very, very similar to the last one, except now you have this Fargate function in here that we're running instead of the Lambda function itself. Same sort of structure. And let's evoke the step function. Okay, so let's, I'm not going to delete it, but do you remember that one's 1125? It's going to get overwritten, and it's only got test 2. We step input Fargate, step input Fargate. We can see we're passing in two things, the commands that gets overwritten here, and then the commands itself has that duration. So if you wanted to run this 100 times, you'd need to have 100 of these. And then you obviously would have some other code that creates this input, but it would create this input and pass it in where you could change your durations and job IDs and all that type of thing. And I probably talked too fast here, but there was the execution and it's starting to run. But if we go here, there we go. See, it's actually already, that was a 25. This one's got updated. It ran the 2. It still says like it's running here. That's again because it takes a while. You know, the wait worked, and then it said that the Fargate timers themselves are still running. Or one is now. See, one just finished. It's because of the shutdown. So it actually runs really fast, but it takes the shutdown. Sits there for a little bit. It's like a full minute by the time it actually all finishes. But there we go. It all finished. Again, now you can see the input to each of these is the delay, and then this command function, which gets passed in and overwrites the command that is sitting in that Docker image itself. So go back all the way out here, that command, right? It's overwriting that command with this information. And because we had that entry point pointing to Python 3.13, it'll all run properly. So that's it. We've gone through and again, had some really basic logic, packaged it up into a Docker image, pushed it to ECR. Then from ECR, that same image was run in Lambda, and that same image was run in Fargate. And then we created 2 step functions that go and either run the Lambda function multiple times, or it runs Fargate ECS Task multiple times. Anyways, I hope that you enjoyed that and learned something. Again, for myself, I find going through the documentation, it's never very clear. And once you get it put together, it's easy. So I do these so the next time I have to do it, I can go back and see the breadcrumbs I left for myself. With that, thanks and have a good evening.